Hello everyone, we are back again with the Bootcamp 2020. Today we are going to cover time series database and the visualization related to it. Sazia, do you want to add anything?
Yes, AWS has a philosophy of having multiple databases, each database for different jobs. And basically, what they are doing is that they have DynamoDB, they have which is good for serverless, but the model is not that good. Then they have compatible document DB, which is compatible with MongoDB. And then they have RDS, which is compatible with MySQL. And for our serverless thing, we are going to prefer Aurora serverless, which we are going to cover later. But there is another type of data which requires another type of database, which is time series data. Data which is coming, for example, in IoT, that at this second this happened, which is in the case of if you are observing some resources or observing anything, continuous data stream is coming. If the data is coming from sensor, that at this time this happened, at this time this happened. So therefore, for that they have just launched 2 months back time series database, and we are going to a time series database. I'll ask Huma to go into detail about this. What is the name of the database? What does it do, and so on.
Okay, sir. Okay, since you have introduced, there's nothing much left for me to introduce. Okay, it's time series database. It's data with timestamp. It's relational database, so you can have meaningful relation across the tables within the database. Since it's AWS service, you get so many advantages out of the box. Like it's high performant. It costs you way less than it would have cost you in other databases with that amount, because we are talking about trillions of data. And it's auto scalable. I'm not sure I'm using the right word, but relational database are like engine based database, so their query power actually depend upon the compute power and storage of their instances, so scalability is crucial. Okay, the three use cases, as sir said, IoT, where we are getting trillions of data with timestamp from so many IoT sensors. The second use case can be DevOps analytics, where you can have data and monitor the health of your app. And then app analytics, where you can measure your customers' interaction with your app and improvise on that. And all those are timestamped, they are a long time. One great thing about TimeStream is you can integrate it with other AWS services as well as third-party services. You can integrate it with AWS SageMaker for AI purposes, AWS Kinesis, AWS Quick Insight for data visualization. We are going to use Grafana, which is third-party open source tool for data visualization. That's for the introduction.
Okay, I want to add something more. There is another problem in time series databases. The problem is you are creating hundreds and thousands of rows maybe each minute. Now the problem is, how do we store it in an efficient way where you don't not spending too much money? What they do is basically the latest data is stored in the RAM in a computer memory. Then as it grows old, it is transferred to different hard drives, and even if it gets even older, it can even be transferred to microfiche, and you can set up. So therefore, what happens is that the huge amounts of data you are producing, you don't lose anything. The old data is kept somewhere where the access time is slow, but it is stored,
Yes.
and the cost is less. And the latest data is stored in the most responsive medium. So therefore, what happens is that you reduce the cost of ownership of that data tremendously. They are saying about 10 times.
Yeah,
Zeeshan,
content.
Zeeshan, would you please continue?
Yes. Okay, let me first share my screen. And let's just look at this image first. This is one of the image from my production app. It's in a high running application, and I have captured the image so that I don't have to go to the application to show name and everything else. But it is from Hariko. My application is deployed on Hariko, but what happened is Hariko has provided us a service, a facility to deploy our application. With that, what Hariko needs to do is Hariko, and I also want from Hariko is to monitor my resources. What is the usage of memory? What is the response time? If any request comes to my application, how much time it takes to respond, how much load on a particular dyno and throughput. And these are the just four examples. There are multiple more graphs available. So these and let me show another. This is one of my production database. It shows the CPU usage of my database, a process and op counter, disk IOPs. These are the graphs which we need whenever we are working on an application and we want to know the resource consumption. We wanted to know the information first in a real time. Second, we need a time based we need data which is based on time. So how much time took to process a command, how much time took to process an request, how much memory it has consumed. These type of information is required to analyze how my application, my process, or my system is working. So for all those things, what you need is you need data of those information. To manage such data, it's a you can assume if an application is running or a database is running, so every other second there is some activities happening. So what you need to do is you need to collect those data, and that means you have a you can have a data in gigabytes or terabytes in information. So you are receiving that lot of amount of data. So then what you need to do is you need to store such data into particular location. In our case, if we think about the rational database or document database, those database are not purpose built for handling such high volume of data first. Second, those database are not scalable for that kind of information. Let's say if I'm using a MongoDB or a MongoDB Atlas, so that particular database is not in purpose built for this. We need a lot of interpolation and many other things to manage our data, to extract the information. Now, what we need to do is first we have the information, we need to store that information somewhere. What I'm showing you at this moment, this is the end result, what we want to achieve. But it requires few things. First, our data which will be generating. Second, we need to store the data at some place. So the data should be time stamped so that we can analyze that a request has started at 9 p.m. and that request has ended at 9:1 p.m. So that means that particular request took a 1 minute. It's a huge 1 minute 60 second is a very big number for a particular for to handling a particular request. If you have 1 million requests, then you can assume how much time your system is taking. So to analyze this information, you need to have information that request has started at 9 p.m. request has, so you need data in timestamp. Then you need to store that information, then you need to query, and then you need to analyze that what is happening with your system. You need to understand, you need to visualize them so that you can understand what is happening with my process or request or my system. So for any service, if I wanted to build in a service, so what I have to do is, let's in case of a MongoDB, the main service they provide is database management, so that you can manage your database. But they also need to create graphs and the process information so that they can display you those information. For that, what Amazon did it, or there are other databases, they have provided us a service called Timestream. So the claim for the time stream, the most important is that it is very high performance and low cost database. There is a very, when you I'll show you the pricing. So you will have a price of, let's say, 0.03 for per million request, or for per million writes, or per GB database. So that's how, so it's a low cost, and it's way much faster because it's not going into the rational thinking, it's not going into the document DB. It's a simple database. I'll show you the dimension and measurement so that you can understand. The most important benefit is it's in high performance. And another one, which is very very important in the era of serverless database, era of serverless application, that this database is a serverless. So you do not have to maintain an instance, you do not have to configure an instance, so you do not have to increase the size scaling of, if there is a lot of data, so you need to increase the storage or you need to increase instances. There is nothing, just it's a serverless database. Whenever there will be more data, it will increase the size. Whenever there will be more requests, it will auto scale. You do not have to worry about this, you do not have to worry about its life cycle management. The important thing in the data we are talking about, like the number of number of or you say the time takes, the minute takes, the seconds takes a request to complete, for this type of data is humongous. It's you can assume that it's coming in, like, in seconds. So every second you are receiving millions of record, or thousands of, or hundred and thousands of record. So when querying such database, to query such database, it takes time because data is increasing. And if whatever database you have, currently we have like a rational or mongo or a document database, when data size increase to such level in GBs or TBs, it costs you time to query data and get the information. So what time stream database did is, as Sajja has explained, that what it does is the recent data which you can configure from 1 day to 1 year, that you want to keep the last 2 days of data in memory, so it keeps recent data separately. And if data gets older than 2 days, it stores in the magnetic database. That's generally we requires. But if I try to do this myself, then what I have to do is I have to transfer the data to some other table or some other database, which will be my ETL or anything. But when I need to query the data, then I have to implement a separate process. The good thing about time series database is you do not have to worry about this. Amazon maintain the data, in memory data, and and the data which is stored as in a magnetic store. When you query the data, you do not have to specify the query from that older data or query from the current data. You have a single interface. You query the data. If it's in a recent, it will coming from the recent. If it's in a magnetic store, that means data is old, not recent and 2 days older. So it will be coming from the magnetic store. You do not have to worry about where the data is coming from. So querying recent data will be faster. And if you are querying more older data, then you will receive that data. Definitely, it might require few seconds more, but it will be quite easy for you to manage. And as I was showing this example, when you are talking about such type of data, mostly what you need is you need last 2 hours, last 1 day, or last 24 hours, last 48 hours of data, which is more important for you to analyze what is happening with your system. If you want to see more older data, that means you are overall identifying the system. So that's also available. But in such type of report, such type of information, you need most recent. So that's why this database is very beneficial and useful. And it's purpose built, it's specifically built to handle time series data. So they have provided you, important thing is, what they did is they implemented is the SQL query language. So you do not have to worry about the learning a new query language. You can do with the SQL query language, and you do not have to learn any other language. But they have given us more functions inside the query language. So for the interpolation, to take the time averaging, and or any many other things. So they have given us these functions inside the SQL query language. So that's why it's quite beneficial. And data is always encrypted, so that's very very important benefit. And this database has a quite beneficial is this database is quite beneficial when you want to analyze data in such instance. Let's say, as Huma has talked about the use case of getting data from IoT. So you have a truck supply coming in, so you have many trucks coming in, from a port to your store, and what you need is at every second you want to analyze the longitude and latitude, so that you can identify that how much time a truck took to reach to a particular destination. So if you are a fleet of 100 trucks, that means 100 IoT devices are sending data on every second. This is a one example. If we talk about the Amazon, they are doing might be millions of transaction a day, or sending a millions of product a day. So they need to analyze such data. So this is the basic reason, or to handle to create a separate database for such type of applications, or such type of requirement. Now let's go to see how what we can do with it. Mm, Amazon time series database. First, I'll show you from the console what we can do, and then let's create database. So when you're creating a database, you have option to create a standard database that will be empty, or you can create a sample database, so that it will fill up your tables. It will create a table which have initially particular data, so that you can understand what the data is and how. So it's just a sample database, so you can understand. So we can create it this way. Standard database will be empty, so we will not be able to understand anything from it. So I'll select the sample database. I'll name it demo tsdb, and I'll keep. So it will generate two tables, and those tables will have data pre-filled. Create. So it has created the database, and inside there is already two tables, DevOps and IoT. So let's go to the DevOps. Now you see they have given us this interface. It has nothing. What you can see is memory store, because we have created that database directly from sample. So they have given this particular table, the table DevOps, memory store of 1 day and magnetic store of 5 years. That means all your recent data will stay in memory, and any data which will be older than 1 day will go to the magnetic store. So uh, if I'll go to the table, and if I try to create a table, so it will ask me these information. At this moment I'm not going to create it, but we can select the database, give it a table name, and we can say a value which will be, the value must be a number minimum 1 hour. So you can say 2, and you can say 2 hours, 2 days, 2 weeks, or 2 months. So that means what you can do is you can specify memory location data, recent data, to be maximum of 12 months. That means maximum of 12 months data will stay in memory. And for magnetic store, you can specify as long as 200 years. So that means any data more than 12 months will go to the magnetic store, and it will stay there for 200 years. But definitely we sometimes we don't need uh, that longer period of time, maybe. So let's say I'm creating it for 10 years. That means after 10 years So the data before that, I don't need it because I don't want to analyze the how much process time it took. So that's why you can manage it. So that's why it's purpose built. So it is not something that you can live for 1,000 years, but 200 years is even enough for us. So let's go to the table again, the table they have created initially. And inside the table, we have this query table button, query. Basically, I was working with it, so they showed the previous tables, previous query. Let me go to query 6, and what I can do is,
Ishan, is it
yeah,
a SQL database or no SQL database?
basically it's in a uh, SQL database requires relationship. There is no relationship. You cannot join one table to another table. So it's not in a SQL database because you cannot create a relations. It's not in a document DB because you cannot create nested uh, documents. It's in a simple database, or you can say it's a record based database. So either you can, to simplify it, you can say it's in a document database, but you cannot make a relationship and everything. So it's somewhere in between. But to query it, you have SQL language. They have given us a SQL language so we can query
Basically, it's a real-time SQL query database.
it. SQL query database. So real time timestamp database.
Hmm.
So you can see databases, the columns over here, and when you click over here, you can show schema. So it will show you schema. So what you have: host name, type is varchar, dimension, as a type is varchar, dimension. I'll explain what is dimension is. Measure value. So that's measure value, measure name, and timestamp. That's the schema. And if I want to see preview data, so what it will do is it will give me directly a query. Uh, Select static form. So whoever is uh, know the SQL
Rishan, please,
can
you have to increase the font size,
still.
or yeah,
I have
on the
that.
Zoom.
Should I increase more? I already did it.
Please do it a little bit more because I'm not able to see it.
Now.
Yeah, okay.
Okay. So now what you can see, if anyone who has worked with SQL queries or SQL database, relational database, who can understand this query, select static from this database dot table. So you can specify the table name where time between ago 15 minute and now. So that's the purpose built query for it. So that means it is saying that query data which is from now to 15 minutes before. So get data from last 15 minutes, ordered by time. So as we have a column of time, and the main important point in the time series database is the main reference point is for us is time. So what you can do is you can call this, and if I'll run the, once you see this query, you can call run. Failed. Okay, so what it did is query syntax invalid one time. Query syntax time. I haven't done anything, and it's maybe, I don't know. I haven't done any changes, but I just changed the lines, and I don't know. So this should not be happening. So don't worry about it. So this is the data we have, and now you need to understand the time series database has given us a sample data, so you can understand, visualize what data is and how you can perform some queries over it. So I just extract all the data and I just call the limit 10. So let me remove this limit. So it will have 88 records at this moment, which should not be the case, but let's move it. Okay, so as you can see, it has a column host name, AZ, region, measure value. Now what you need to understand is it's a simple query and it's giving us a data just like we can see in normal table format data. But the important point is there are three things: dimension, measure value, measure name, and timestamp. This is what you add in your database. So what the dimension is, there are few important concepts which you need to understand what they represent. For that, let's go to the document and how it works and concepts. First of all, what is time series? So if you see this data, whenever you fetch a data, extract a data to particular time interval, so I say extract data from for last 15 minutes, so we are taking a time series. So these records are for particular time series. So that's there can be 12 record, that can be 100 record, or that can be 500 records. So time series is in particular time interval and you have a multiple record inside it. So that's the concept number one. A record is a single data point. This is the one single record. Whatever we have added, I'll explain you what this is and how you can add data and it's okay, one more thing. You cannot delete data and you cannot update data. In time series, it's an own append only. You can add data only. You cannot delete or update data. Okay. So dimension, the most important part, dimension and measure. An attribute that describe metadata of time series. Basically, what we are trying to analyze is that we want to measure us CPU utilization. Like in this example, we want to analyze the memory usage. So how much memory has been consumed, right? We want to analyze how much response time it has taken. And we want to analyze that response time on particular information. That means if I'm working in AWS console or AWS application, I have a data. I have data in multiple regions. I have a data in multiple machines. I have data in multiple Lambda functions. So what I need to do is I need to extract the response time of a particular region. I want to extract a time response time of a particular machine. So for that, what I have to do is I have to keep that information in the form of dimension. That's what it is called. Dimension consists of a name and dimension value. This will, I guess, will explain you more. Considering a stock exchange as a dimension, the dimension name is stock exchange and the value is New York Stock Exchange. So what you wanted to do is you wanted to analyze a stock price in multiple stock exchanges. Like if you are trying to analyze a cryptocurrency, so you have multiple exchanges for the cryptocurrency. So what you need to do is you want to see the value of Ethereum in X exchange and Y exchange. So you will be receiving data uh, for particular exchange, Ethereum value, second exchange, Ethereum value, third exchange, Ethereum value, so that you can query data based on dimension. So that I wanted to know price of Ethereum on Binance exchange. I want to know the price of Ethereum on coin market cap, so that you can extract data based on those dimensions. So your data will be in multiple, same data can have multiple dimensions. So that Ethereum price at the time 9 p.m., what at 9 p.m., what was the price in Binance and what was the price at coin market cap at the 9 p.m. So for that you need the dimensions. So for that you have dimensions. So whenever you are storing your data, it must have at least one dimension. In another example, you have a data in multiple region of your AWS. So your region can be a one dimension, so that you can, let's say you are running 100 EC2 instances, 50 in ES East 1, 15 ES, US East 2, 15 US West 1, and 15 in US West 2. So you have a data in four region. So you were receiving 50 EC2 data from EOS East 1 and memory utilization at 9 p.m. So you will be receiving at 9 p.m. memory utilization from 4 regions. So you can analyze data based on that dimension. So that's why dimension is important. Again, IoT sensors, as we have discussed. So you have a fleet of 100 trucks running on the roads. Every truck is sending a data. So you need to identify longitudinal latitude of at a particular time of a truck one, truck two, truck three. So for that, you need to have dimensions. So dimension is important. You must have what you say single dimension inside your database, which is mandatory. And you can have as much as 128 dimension in particular table. So if I'm creating a table in my Timestream database, so at this moment I have 3 dimension: host name, is it region. You can go up to 128 dimension. That's the limitation. 128 dimensions are far enough to analyze the data. That's more than enough for us. So that's the dimension and the measures. So it's quite simplified. So you do not have to create your column that I want to store a first name, last name, email. This is not for this database is not for storing a student information. So you do not have to specify a column name so that I have a column name, first name, last name, email. I have to specify a column name, CPU utilization, memory utilization, longitude, latitude. You do not have that column specification. So that's why I was saying it's not neither a SQL database or neither a document database. What you have is you have a two column name, measure name and measure value. So that measure name and measure value is something you actually want to analyze. You want to actually want to uh, uh, analyze that particular data. So that's why they have given us measure name and measure value. And inside that, as you can see the example, your measure name will be stock price and the measure value will be actual price of your stock. So in our case, if you can see, we have a column name measure value and we can specify type. I'll come to the type later. So it's a value and measure name is CPU utilization. There cannot be any other column. You cannot say my column is CPU utilization. There is no other column. It will be a time, it will be measure value, measure name, and the dimension which you are providing. So you can provide 100, 128 dimensions that can have a name, but the value which you want to analyze will not have a column name. So as you can see, what this data is doing, this data, if you try to understand, it's DevOps data. It's trying to analyze few EC2 instances and their CPU utilization and memory utilization. So it's saying in EU North 1, uh, it's a region and it's a zone EU North 1A. Host name, that means EC2 machine has a name host X356, has CPU utilization of 69.165 at 17:30:06 time. So at the February 2nd, at this time, the CPU utilization was 69 of host X31, which is resides in EU region, EU North region. So that's how you have these data, and you can then follow create your queries and understand those data. Timestamp, again, definitely the complete information, everything is run around the time. So that's a timestamp column. Then definitely you have a data table and database. So that's basically it. So whenever you are storing a data, you have to provide at least one dimension, and you must have a particular measure value and measure record, and then the time.
The measure value can only be one.
Measure only can only be one at particular record. Measure value and measure name can be one at particular record. Dimension can be 120. And in a particular table, as you can see, it's a CPU utilization, it's a memory utilization at this moment. In this table, we have a two different type of measure names. CPU utilization, memory utilization. So in a particular table, you can have 1,024 measures, not more than that. That's also a limitation, but
You
definitely
just said, you just said 128 dimensions.
1,028, 1,024.
No, you were saying you can have 128 dimensions.
Yes. So then can be host, AZ, region, device name, XYZ, ABC. That's the dimension.
Uh-huh.
You have a measure CPU utilization and memory utilization. At this moment, we have two. We can have 1,024 measure names.
Okay. Okay.
And a particular record, you will have one. But in a table, you can have multiple measures. And those
Uh-huh.
measures can count up to 1,024.
Uh-huh. Okay.
So now what you can do, if I'm just showing you one or two example of query, and they have a sample query as well. So what you can do, that let's say I wanted to uh, see data, it's an order by, I want to group data, group by host name. Okay, I want to do group data by host name. And if I'll try to run, it will not work, because whenever you are trying to run the data based on group by, so you also need to specify a specific column, host name, and basically what you are trying to analyze. You are trying to analyze your measure value. So for that, you have to aggregate. You must have an aggregation. So what I have to do is I have to call average time must be aggregate expression. Okay, so I have to also specify time over here, and so it will take a bit of time for us to because a normal quest, it will be exactly like SQL query, but there is definitely a few columns or few functions which you need to understand. So what you can see is as average measure. So what it's trying to do is on each host, it is trying to measure, it's creating average of particular host. Now if you'll see, you might see a duplication of record. Let me just, you can increase the rows per page. So you'll see that you must have duplication over here. And why it is, yes, you have duplication in group by, you should not have, because there are regions as well. So what you can do is you can also specify the region, and then you can specify region here as well. So you're seeing this host TPL in ES2 average. Uh, okay, I have to also specify that if I'm trying to measure the CPU utilization, or I'm trying to do the memory utilization. Let me just copy the CPU utilization. So what I'll say is, um, where time between this, or I can say measure underscore name equals CPU utilization, and so we are talking about only CPU utilization. And as you can see, we have only 23 records. So what it does is it groups all the record So EU North 1 host XYZ has an average CPU utilization of 17 in last 15 minutes. Why last 15 minutes? Because we have taken the data for last 15 minutes so that you can identify the CPU average CPU utilization of last 15 minutes of a particular machine in a particular region. That's how you can work with the what you say your data. Okay. Now what you can do is we have a sample queries. So what we can do is you can go sample query. Let me just recent. Oh no, I have to create another tab. Otherwise, it will overwrite. If I'll be staying in the same tab and I'll go to the sample query, it will overwrite my existing query. So I have to create a new tab. You can create a query tab from here. Go to sample query, and they have given us some quite uh, very what you say queries which you can create as a sample so that you can do process on your data, so you can understand how you can do this. So as you can see, they have given us a query which says select region, time zone, host name, bin, and okay, what bin is basically, it says combine the date times of last 15 second. So if you have a timestamp coming from every second, so it will combine and it will give you, let's say, uh, 9 p.m. 1 minute and 0 second. Then next time span will be 9 minute 1 minute and 15 second. Next time span will be 9 minute 9 p.m. 1 minute and 30 seconds. So it will combine those data. So it's binning a data. So when you have bin data, to access it, then you have to bin the data in uh, here as well in group by, so that you can fetch data as a group of particular time span. So what it's just trying to do is it's trying to average out the CPU utilization and tries to create the 95, 95, and 99 percentile of usage. So for our case, and it is doing this for particular host, host HOV something. Syntax fail, query one line 8. I don't know why it's do this and then start running. Okay, so now you can see we have only 5 records, and it's an US each one host time span. Now you can see we have a bin of 15 second. If we have a data, so you can see 2 15, 58, 45. And if we do not have data, then it will be a different type of data. Otherwise, it will be. So you can see average CPU utilization, 90 percentile, 95 percentile. So you can use these queries to analyze your data. Now, now we'll go to the code. So how can we do this with the coding, and how we'll generate the data, and how we'll add the data into the database. But what the point we have reached is we have generated the data and we have ingested data into our database, and then we have learned that how we can query and extract the data. But you cannot analyze based on these numbers. For that, you need to have visualization. You need to display them in what you say graphs. So for that, we have a multiple services. We have Grafana, we have QuickSight, and there are many other services. One which we'll look into today is Grafana. So first, let's go to the code, and then we'll go for the visualization. Okay, so I have already set up this code so that because writing into the database is quite a simple task. Just if you understand what the dimension and record is, then you do not have to worry about anything else. So let me go to the stack, and as you can see, just created a time series database, give it a name, and then create a table, give it a database name, and give it a table name, so that you create a time series database in your stack and create a time series table. inside the database. That's what it does. And sometimes I have, or our team also has experienced a problem with this time series, that sometimes it tries to create time series table first and then database. I don't know why. So for that, AWS CDK has provided us a feature that you can depend your one construct to another. So I'm saying time series table add depends on time series DB. That means whenever you try to provision, that means you are trying to create a database or table. So if you try to create this table, so for before that you must have to create or provision this database. So in that way it will be a sequential. So it will create database first, and then it will create time series table, and then it will it's done. Then what I wanted to do is, at this moment you might be writing to your time series database from, you can write from direct IoT core library. You can write to your time series database from Kinesis, Apache Flink. There is a Telegraph. So there are multiple options available to ingest. It is called ingesting a data into your database. And you can do it with your AWS SDK as well. So what I'll do as for this example, I'll write a Lambda function. I have created Lambda function, and from Lambda function, we'll be writing data into Timestream database. So for that, we need to create a Lambda function, and that Lambda function, as we have seen, one service need an access to another service, so we have to create a policy. So I have created a policy statement, effect allow, and what actions we need. We need to write record and describe endpoint if we want to read something from the only for the review. And resources static, you can specify specifically DB name so that it can only access this. At this moment, I'm not doing this. And then you will add this policy to your Lambda function. So my Lambda function, it's just as we have done quite many times, specifying the runtime name, and then we need to pass this database and table name to our Lambda function, so that our Lambda function knows which database that function needs to write on. So I have specified the environment variable into the Lambda function, and then add the role policy to Lambda function. So that policy will be added inside our Lambda function. So our Lambda function now can write on time stream database. That's the simplified two construct of time series database and table. Now let's move to the Lambda function, because actually we will be writing from this function to our database. One more thing to understand, you have every time you want to work on a particular service, you have documentation for each and every service, must explore those services. So you have a code sample over here, how you can write query from your time series database. So to write this time series database, first what you need to do is you need to create an HTTP agent, and then you need to create a time series writer so that it can read, and max retries 10. That means it tries, when you it tries to write on the database, if there isn't any failure, so it tries 10 times, and then it's uh, gives an error, or you can then read that error and you can do some action over it. HTTP options, so timeout is 20 seconds, and then you need to specify the HTTP agent. So that's the basic syntax to create a time series writer, so that you can write on a database. Then to specifically write on a database, you have this. So instead of going, you need to call write client, write records, and you need to specify your object. Let me show you now. So I have created an agent, then I have created a time stream writer, so that what I'm saying, that try to write it, and if tries to write and there is no data, so timeout in 20 seconds, wait for the 20 seconds. Dimension, as we have discussed, I have explained in quite detail, so that we can understand that we have a region, AZ, and host name. You can specify your dimension, whatever dimension you want. So we need to have array, and it should have an object. So for each dimension you have an object. So if you have a one dimension, then there will be one object inside an array. Name will be your dimension name, value will be the name of your dimension. So we are saying my one of the dimension is region and its value is US East 1. So definitely this data will be coming from your EC2 host, your IoT device, or your particular Lambda function, or from anywhere. That data will be coming from, at this moment, this is hard coded data. Let's say I wanted to add device ID, for example, just for the example. So I can say the IoT D1, 2, 3, 4, anything. So that's something your device ID is coming from, and this is your dimension. Then what you need is basically you need an array of records. So at the particular time, you can add multiple records. So as you can see in a simple query, mhm, in query 6, I guess. Uh, Demo ts-tp. Uh-huh. Order by time, demo ts-tb. Why it's not returning the data?
Ishan, maybe last 15 minutes have passed, you know.
That's what I was trying to change. So I made it as 16 minutes. So get the data from last 1 hour. So now what I was trying to say is this is one record and there is another record. So maybe you want a particular record for memory utilization and CPU utilization you are receiving at the same particular time. So from an IoT device, you are receiving a longitude and latitude as well. So you have a two record of a particular time period. So what you can do, you can have one measure at a particular point in time. So what you can do is you can pass multiple record inside an array. So what you can do, what I did at this moment is I have created an object. That object can have these five properties. Dimension accepts this array. It should must have at least one, and at the higher side you can go to 128. And then you need to specify measure name. In this case it is a CPU utilization. Measure value, in this case it is a 36.6. It will be coming, must be coming from your instance or some measure value type. It's a double, so you have around five types, maybe um, if not here, it should be here. Yes, you can have a data type of begin, boolean, double, and varchar. So your measure value can have these four type of data types, nothing else. You cannot store true and false. And time.
Zishan, it said Boolean. You can store true and false.
Oh, sorry. I guess any other data type which you want to manage. It's begin, boolean, double, and varchar, but not any other type of data. But it covers most of the data inside this. Basically, it covers everything. Okay, so time. So you can specify time now. what you are trying to do is you have a two record at the same particular time period. That time also will be coming from your device or your instance. So I have created a two record. Now await write client dot write record, and inside that okay, inside that I have to specify an object, and that object require database name, table name, as we have just created the time series writer. It does not know which database I wanted to write. So while writing a record, I'll have to specify database name and the table name, and then I have to specify array of objects inside the record property. So record property at this moment, I just specified these two. Otherwise, I just created you this to show you that what you will be doing actually is you have created a record, an array, and you have added the two objects. So that means you are adding a two record at the same time. So that will so you can manage multiple information of a particular time. That's it. So once you run it, it will write. What I'll have to do is let me just generate it a random number. It's a CPU utilization, so it will be 9 multiplied by 99 plus 1. So it will generate from 1 to 100, and it's a memory utilization, so I'll call it, maybe we have a system of 128 MB memory. It will be 0 to. So whatever data type you have, you must have it inside the string. The time stream database will manage it as a double or boolean or breaking. But while passing over here, it must be in string. So otherwise it will give you error. So what I'll do is whenever I'll call the Lambda function, it will generate a random number and we can see different type of data. So we are done with it. I'll try to run it. Let me check the database name because demo TSDB and I do not have this DB. Okay, demo TSDB, I have already created it. So let me just change the name. Okay, so now okay, while it's deploying, we have reached to the point that we have generated the data, ingested the data, and we have a lot of queries to group and analyze the data. But for the visualization, we have to go to Grafana while it's setting up. Let me go to the AWS and show you. Problem with Grafana AWS is Grafana is an open source project which is run separately by Grafana Lab. But what AWS did is AWS uh, took this open source project and provided us a managed service. At this moment, it is in available only Europe and US East one. Plus, it is in a preview, so you have to request it. Otherwise, so you have to specifically ask. It will take few days. Then it will be available to you. So at this moment, I have requested it. I do not have access. So what I'll do is I'll show you on the Grafana cloud and I'll connect it with the time stream database, which AWS gives us facility. So we'll connect it. But what will be, I'll be showing you in the Grafana cloud, you can be doing can do this on AWS managed with AWS Grafana's managed service as well. So, okay. So for that, what you have to do is you have to create your account if you do not have created initially. Let me just run a cloud. So you have to specify your email address and everything. Just to specify your email address, your password, and it will create your account. It will ask some information. I have to show you. Mm. So it will ask project name. I'll say first project. Will ask the URL. So it will be grafana.net. So anything you will specify here. So if I'll say okay, let's say Zeeshan.grafana, not available. Its subdomain is one word. It's available. Let's create. So it will create a cloud service. It asks few details. Either you use it or skip it. You do not have to worry about it. Let's skip the tutorial. I'll show you. So we have this Grafana front interface. Let's go for the Lambda to generate the data, and then we'll come back to the Grafana cloud. Okay. So now we have a time series database, which is demo sample DB. It has table, and the table has nothing. It's an empty. And what we can do is let's go to the Lambda. So we can see that go to the query table. This is something annoying that it sometimes it's useful that it's creating the keeping the queries tab, but if they are keeping that query tab, so if they kept that based on database, that will be a more better. But even then, there is no end for the wishes. Okay, so at this moment there is no data in my this database. What I'll do is I'll go to the function configure. So what I can do is I'll call this test, and it will start sending data into the database. So just create the test. Successful. Let's see what we have in database. Here you can see host 3. Now let me just show the uh, data again. Region US East 1, AZ1, host 3, device, and then you have this information. So you can see host 3, AZ1, US, these are the hard coded information. Measure value it generated randomly 96 point something, 35 point something memory utilization. Now the good thing is because I have created it as a random, so I can run multiple and can see the okay. So let's run it again, and I have a randomly generated measures memory utilization and CPU utilization, and then I can have run on multiple queries on it. I can group it or whatever you can do with the SQL query language. The important part is aggregation. You have to aggregate the data. So you want to see the what happened in last 10 minutes with the ship utilization. Is it peak to at what stage? So you want to calculate the total or average of a ship utilization of a last 10 minutes. So that's why you have this database and all these queries and all these facilities. So that's what we have. This is a simple, you can do simplify. It's a simply simple to write on the database. Main thing is conceptually you understand how the database works and what database provides us. Writing to this database is not something which is very difficult, so you need to understand this. For the Grafana, at this moment we do not have any construct from the AWS because it's still in managed service. So let's go for what I was trying to show you. Okay, so from here what you can do is you can click on the login Grafana. It basically tries to set up everything sometimes, so it's takes time, but should not take that much time. Loading Grafana. Hmm, okay, sign in with Grafana and authorize application. Okay, so I have to verify this email. Okay, so now it's okay. Now we are my on my account. What we can do is again go here. The important part is how you can connect with it with the time stream, and Grafana gives us all the charts. You will connect your database, time stream database with the Grafana. You will specify your queries and it will show you into different graphs, so you can specify those things. So once it is done, I'll show you. Meanwhile, what you can do is uh, you know, at this moment, AWS managed service and Grafana cloud itself are quite costly. So you can run it directly on your instances as well. For that, you have this download option. If we will have time, I'll show you how you can do it with the Docker as well. So instead of going, I'll show you with this. And what you can do is inside the download, with the one single command, you can run with Linux, Windows, Mac. They have specified all those things, but interesting is this Docker. You will just run this line on your system, and it will run Grafana on your system. You do not have to go into these Linux and Windows and everything to set up Grafana on your system. I'll show you if we have a time. Okay, so we are on the Grafana dashboard. What we have to do is we have to configure our data source. But before configuring a data source, we have to go to plugin. By default, time stream does not exist here, so we have to go find more plugins. It will go to the Grafana list and specify time stream. This is what we are doing from the UI. But if we, as I showed you this one, where it is with this Docker, so you do not have to do anything. I'll show you. So once you uh, find the time stream plugin, what you have to do is go to installation. And because you are logged in into your account, so it will just ask, give you the click on the install, and it's part of your Grafana dashboard. Now you can go back to here and refresh it. It will have inside the plugin. Not yet. Mhm. It should be here. I'll show you in my another account now. So what it will be here. And then what you can do is once you click on it, you can specify everything related to your data source. And then inside your data source, you will select the time stream. So at this moment, it is not here. So I'll go to my other account and show you. Let's just check one more time. Just it's time stream. You will click on it. It will show you everything. You just don't have to do anything else. It is here. Go to data source, add data source, select time stream. Now it will ask for the setup. So you have to specify the name, then your access key and credential. Then you have to click specify. So I'm not going to show my access key at this moment because I'm using this account continuously. So I'll just remove the screen for a while to add this access key, and then I'll show it again, just for the sake of security of my account. Okay. Okay, so I just specified my access key and my secret key, and now what I can do is I have to specify the region from which region I have to use. So at this moment, my database is in EUS2, I guess. Let me just check it. EUS2. Okay, so in EUS2, EUS2. Okay, save and test. So it will say testing. There is some communication error. Let me refresh it. There is no instance. US West 2. It does not have US West 2. Okay, so I have another one, another database in US East 1. So let's test this. Okay, so it's connected. So I have created in US East 1 time series database as well. So it will work with that database. So we just have to learn how it works. So there's nothing to worry about it. You can see sample DB. Then you will select, I'll select DevOps. So I'm using the sample database so that because it will have some data. So once you are connected with this, you are done with this. You can see dashboard permissions. You do not have to worry about this at this moment. So once you set up, done with the setup, go to create dashboard and you can add a new panel. In this panel, you can specify what database you have. So you will select from here, you will select the time stream and it will show you the demo DB sample, everything over here. It's trying to load. Why it's taking time? Okay, so let's try this. Okay, so we have selected database. It's on a table, and no, it's not working. So it should mention the
Maybe
names.
it
Okay,
doesn't have any
now
table.
we have.
Okay, any data.
Yeah, because at this moment the confusion is I have a two Grafana cloud account. I have a database in ES used one is two, so just to test it. So that's why it's so much. Okay, so now what we can do is let's go to the database and the query we have seen. Let me say sample query, which shows us the average time and everything. So I'll copy this query and paste this query here. See the transformation. It shows no data. What I can do is now I'll specify the graph. I can select the graph, so it says nothing because the time spent 2 hours. Let me change it to 10 hours. Okay, and then again go to the transform.
Ishan, it will be a good idea to first test the query in Amazon.
Yes, yes. Okay, so I have done this. What I have to do is I have to uh, change my region because it's running on a different region. So I have to go to that particular region because it's work with this database in this region. So here I have this query and demo sample DB. It fails node sample DB found. Okay, so it says demo sample DB and here we have. Okay. Okay, now we have data and we can see different type of graphs, bar graphs, as you can see here, And the interesting part is you can select, go to the display, show all values. You can specify limit values. You can, so you have a lot of control with your graph, whichever graph you wanted to use. In bar graph, as you can see, you can show all values, horizontal. So it's quite good. So let's say selected the bar graph with this style, and what I can do is I can click apply, and I have this graph. I want to add another graph. Go to add new panel, select the database, paste the same query, change the name and transform, and select this. Okay, why again? Okay, 10 hours, and will
Zeeshan,
be
I
better
think
from.
we got a hang of it, and we are up 5 minutes out of time.
Okay, so then what you will have, what you can do is, uh, let me just at this here. What you can do is it's a new dashboard. So when you will try to move somewhere, it will you have to save. No, save the dashboard, and you will have a particular dashboard in your home page. Newly created dashboard, and you will go to that particular dashboard, so you can see the Grafana cloud this way, and whatever data you have. So this is a complete cycle. Actually, we wanted to reach here. For that, we have to fetch the data, collect the data, whatever data we have, time stream data that is based on timestamp, ingest into the time stream, run your query, group, aggregate your data, and then you visualize over here. So do we have 5 minutes so I can show you with the Docker?
I think
Or
that's not required. No, that's not required.
okay, never mind. So you just have to run this. If you have Docker installed, just run this query and you will have this interface without doing anything else. So you do not have to worry about going into the, if you want to run on your local machine, so you do not have to go for this all these steps. Just go to the Docker and um, run this command, because it requires the plugin time series plugin. So you want to connect your AWS database and specify the Grafana time series over here, which we have mentioned in the repository. So you will be good to go. Yes. So any,
I
so I
think
guess it's done. If
okay. Bye bye. See you guys in the next class. Bye bye.
okay, bye everyone.